Okay, hello again. I'm going to try to show you one example of using the Z statistic to figure out proportions of populations that meet certain criteria. So this one is about mercury in fish. This is some real data I found in a journal somewhere or another. But to eat, I think it's swordfish in Italian waters, if they have more than 1,000 microgram of mercury per kilogram, they are considered unsafe. Microgram per kilogram is parts per billion. So that's, that's a relatively small amount, but mercury is a terrible poison. And they don't give the sample size, or I didn't write it down, but you get about 1,082 as a mean for their sample with a 95 standard deviation. It's always helpful to draw a picture first. So we'll draw our line here. This will be our mean, and if it follows the normal curve, it will be symmetrical to both sides of the mean. The mean's 1,082, and what we want to eat is only down in here at less than 1,000. So this is kind of the deal. Let me draw this down the middle because our Z table actually only considers 1/2 of the distribution at a time. I'll show you that in a minute. But so our Z statistic is our X, that's our target, our 1,000, minus X bar, that's our mean amount of mercury, and that's divided by the standard deviation of the sample. Actually, they say that should be the population standard deviation, but we almost never have that. So anyway, that is 1,000 X minus 1,082, our mean, over 95, and that turns out to be negative 0.86. Now let me switch to another screen here and show you the version of the Z table, the Z statistic table that I've provided for you. So right up here, it's the area under the Gaussian error curve from 0 to Z. So here's Z down the left side. That's the decimal place, the 10th. And then going out across here are the hundredths. So this is 0.000102, out to 0.09, and then 0.10, 0.1, et cetera, et cetera, et cetera. And let me just see if I can scroll this down a little bit. And so, whoops, I think I went the wrong direction. Let me move my picture out of the way where I can get this here. Right, so down here at the bottom, you can see it only goes as far as 3.99, and that area is 0.4999. In other words, essentially 0.5. Out at infinity, the area from 0 to infinity is 0.5, and from 0 to negative infinity is also 0.5. So different tables are set up differently, but here's 0.8. Whoops, let me get it up a little bit more. All right, 0.86 has an area of 0.3051. Let's just round that to 0.305. And let's go back to the whiteboard now. All right, so our area 0 to z, or negative 0.86, is 0.305. So that 0.305 is this area here from 0 to z. And so the area less than 0.305, sorry, that's our safe zone. And that is 0.5, the total from 0 to negative infinity, minus 0.305, and that equals 0.195, or 19.5, or just under 20% of the fish you catch, the swordfish that you might catch off the shores of Italy, are safe to eat. That's not very satisfying for a fish eater type person, but anyway, that should give you a little bit of an idea how to do these. Some of them are a little more complicated, but the thing to do is first of all, draw a picture and figure out what you're trying to look for. Anyway, that's it for the moment. Let me stop the recording.